Hey everyone, welcome to my series of Golang introductory exercises. You know, what better way to learn a new language than to practice it? I have added in the description below, you will find the repository for this exercise that we are going to do today, and my website where I will be detailing this exercise. Maybe it's easier to follow there. So today we start with a very common scenario. One of the introductory exercises will be how to make a web request in Golang and how to parse it. First as a string and then as a struct, as a Go struct. Okay, so let's start. I have a repo called Go Starter. Let's just make a folder just to keep things clean. HTTP response parsing. Right, and here, as everything in Go, we need a main.go file. Right. So now we have the main.go file. Now this is VS Code. When you enter for the first time a file with the extension .go, VS Code will detect that and will ask you to install a whole bunch of extensions. So that you have, IntelliSense and all the utilities that you need in order to develop in Golang. I have already done that, but you will probably have to install it if this is your first Golang file, and you might have to restart the editor VS Code once. So as everything in Golang, we start with the package name. So package main. Now Golang detects that and lets me insert it. So basically we want to have we will have a function main, but we want to have another function which will make a web request and will parse it as a string. So let's just write that. So let's say func get content as string. Now I just chose some random API that's available for free on the web. So just for the sake of example, you can use anything that gives you back a JSON or whatever. Doesn't really matter. You can make a web request with anything, any URL. You might not get JSON, you might get HTML or whatever. So we are going to, this function will receive the URL as a string. And we call the function get content, so we want to return the content as a string. So we will just say string as a return type. Well, this would be the return type. Now this tutorial assumes that you have some basics already. You went through them, like how do you declare a variable in Golang? How do you what's a struct, a Go struct? Now, if you don't have these basics, let me know and I will make those tutorials as well. So now in order to make the request, we are going to use the get method of the HTTP built-in package. So Go offers these packages to make your life easier. So we will say http.get get URL. When we save the file, Go detects that we want to use the get method from the HTTP package and adds this import automatically. Right, so now this method returns two results. Let's say it returns the response itself and an error. The error is nil if there was no error. So we will just say response and error. And basically we let's first check if we had some error, right? So this is a very simple program. So we just want to stop everything if there was some error, right? There's no point in continuing. This is a very small example. So if we had an error, like error was not nil, right? We want to say panic with error. So what panic does? Panic is another built-in function which will just stop the execution of the current thread, the current Go routine. The current Go routine is the main one. So essentially, just stopping our application with a non-success code. So success would be 0. Non-success would be higher than 0. So if we had an error, we would stop with there's no point in continuing. There is no content to parse that, right? So we can also just document this. Like, let's say here we are making the web request. We exit with a non-zero status if there was any error during the I have a funny keyboard during the request, right? Another thing that we should do is we should use a mechanism where we have to clean the resources that we consume. So we would say response body close, and we will defer this, right? We will just say, okay, and what defer does is it let's say it schedules the cleaning of the resources for when the current block finishes. What's the current block? The current block is this function, right? So when this function finishes, this cleaning of resources will take place, right? So now we just want to use the a method to just parse the response, right? So so we just say and this is in the package io-util. Go is really cool because it's very it has some one of the main strengths is that it gives you some packages with very simple to use methods. So io-util dot read all, and then we pass the response body, right? So then, as you can see, this has imported the io-util package, io-util, automatically when we save the file. Now, this returns this returns an array of bytes. As we see, this is cool about Golang. It can return two things, like two functions can have two outputs. So one of them is the array of bytes, which is the actual, the actual result that we want, and an error, which is again nil if there was no error. So in this case, we will say, let's say, whatever, bytes and error equals read all, right? So this we read everything into these two objects. Now, to be quite honest, we don't exactly need this error here. So if there was some error during the read all, we don't really care. So we're not going to use this. So we'll just say replace this with an underscore. What this means is that, yeah, I know there is a second output of this read all function, but I don't care about it. I choose to ignore it, so I'll just write underscore. Right. So then we just say, because we said here return a string, we just want to return. We want to return the array of bytes as a string. So the way to do that would be string to stringify the output here. So this is a byte array, and we just return the string output of this byte array. Sorry, we return the array as a string. So essentially, this is it. Now we just need to to use this. So we just say like get content as string, and then we just pass. I have a random API here, which gives me dog objects, whatever. So right, and then what we do, let's just also see what happens. So we just say format.print line s. Yeah, so we want to also see what the response is. So as you can see, I'm using the print line from the FMT package. Now let's just let's run this. Let's run this and let's see what happens. So to run things in Go, we write go run main.go. So what we have is we have the response of this API as a string, right? So this is a JSON object that is like stringified. Now, what if we would like to have the response as a Go struct, because it has two properties, it has message and it has status? What if we we had some object some structure with those two properties, and we want to actually return that instead of a string? This would be more useful. So let's say we have another function. We have a func get content as Go struct. Right. So again, we take the URL and then we return. We would let's declare a struct so that we can specify the return type, right? So we need to specify the return type, so we just create this struct. Let's say, so the way to declare structs in Golang is you say type. Let's say this gives us some dog images. It just says message and status. Let's just call it dog dodge. Why not dodge response, dodge response, and then it has a message as string, and then it has like status string, whatever. Oops, I did not say the most important thing. This is a struct. Right. So now Go is really strict. Like if you have capitalized this here, it assumes you want to export it for other, like this is your API and you want to export it for others to use. So then let's just add some comment, whatever, dodge response. The comment has to start with again with the name of the type. This is just a dog response representation. Doesn't really matter. It's just for the sake of example. So now we want to return this as this type of struct from our function, right? So we will make the same request as here, but instead of returning a string, we will return this as this type of struct, right? So let's, okay, this is a kind of an ugly naming, but let's say get content as dodge response, right? The previous naming was as go struct is kind of generic. You might have multiple structs. Okay, so essentially now the code to make the request is the same. We don't need to change anything. So I'm just gonna shamelessly copy paste the part here. If my rule is if you need to, if you find yourself needing the same code like 3 times, it's you know, you should refactor. Like we could make a method that says like, you know, like func fetch URL string, and it gives you you know, some byte array or something, some byte array, whatever. But and then we would reuse this function. We would, instead of doing these 2 blocks here, we would just say fetch, right? Because it's the same lines of code, so why copy paste? Well, I usually do this refactoring for usability when I need the same piece of code 3 times. I just need it 2 times here, so you know, why bother? So now we have the code to make the request here. Oops, no. I also need to you know, to read the body. So we need the same construct. We need to util that read all r.body, right? No, there is no semicolon in Go. But now, how do I? So now is the question. Okay, how do you transform the array of bytes? This is what this type is. Oops. Yeah. Colon equals, yes. Because this was like you either say this equals, and you need to have previously initialized the variable, or you declare it and initialize it with colon equals, right? So then we have this b is a byte. Now there is this convention in Go that you should name your variables with just one letter. I have like mixed feelings. This doesn't really sit well with me, but I will make a separate video on naming in Golang. I think there should be a balance between too much, like maybe this name is way too long, right? Get content as the name of a struct. It would be overkill, but so you know, you might rename this as dodge, response or whatever. So I think there should be a balance between naming it like too long or naming it like just something extremely cryptic that's very hard to understand. So I think there should be there is a sweet spot in the middle that should be used, because I have a rule in all my all the time in my work. I have understood that you always write code for your colleagues, right? It's never for you, for yourself, never. All the time when you think you will be the maintainer, it never happens that you're the maintainer of the code. It's always somebody else. So if you type cryptic stuff, if you name your variables like or functions, like function A1, variable A2, A3, A4, nobody, including you, will understand later what's going on. But this is another discussion. So let's just get back to the initial functioning for the sake of finishing the exercise. So now that we have the byte array from the again from the as response from the URL from the API call, now we want to create a sort of a holder struct variable. So we will just say var dr is my Dodge response struct type. This is like a holder object which will hold our which will contain our parsed response, right? Because this has the properties that we are interested in. So now we created this holder, but now we are going to populate its properties, right? How do you do that? You do that, but well, you know that you have a JSON in there, right? So we do that by saying, JSON. This is another library, of course, on Marshall, and then we pass this receives I need to say for this to be understood, right? So it needs the byte array. So we say B, and then it needs a pointer to the let's say to the target structure that you want to have populated, right? So then we would have a pointer. A pointer would be like this, dr, right? So this is and of course we also want to we want to see if this was successful. If this whole thing was not successful, this would now, what this does, this now populates the like fills this struct, and if this would fail, this method would give you back an error, right? So it says, as it says in the document, it gives you an error. So let's see let's do the same mechanism as we did here. Like if there was some error during this parsing, we just say we just exit the program. So let's say parsing error colon equals this, right? So that would be our error during parsing. I cannot say this because I declared it here already. If parsing error is not nil, right? Then we have an error. Then we will just say invoke the same panic with parsing error. So now all we need to do, we have, and this has an error. Okay, so we are missing the read. Obviously, we need to return. We need to return our struct, right? So let's also use this function. So now we have this function. Why not increase this? We have this function, and we are going to use this as well. And we are going to use it here for the sake of comparing the outputs from the string method and the struct method. So let's see how that looks like. So we have you know, we have struct equals get content, get, what's going on? Something is, I wrote too many G's. Get content as double response. And then let's just use the same API, and then let's see let's see the result. Format the print line str struct. So let's see what happens. Go run main.go. Yeah, so as we see, we get the actual struct, the properties message. The message was, so this was a string one, and this is the struct one, and the properties were populated with the results of the as you can see, we have success in the status property, and we have we have the actual message in the message property. Yep, that's all. Like if you liked, let me know in the comments below if you found this useful. I appreciate constructive criticism. This is basically for you, not for me. This series of tutorials, check the website in the description for this whole explanation if you want to also read it, and I'll see you guys in the next video.